This is the fifth video on rotations in the transformation geometry unit. So we've already established the corresponding sides of rotated figures are congruent, but what else is true about those corresponding sides of rotated figures? So let's go back to the TI-Nspire software and go over to Tools, Templates, and we're going to go down to number 6, Slopes. So it's Tools, Templates, Slopes. And we want to rotate 90 degrees, which it says right here. So we're going to go ahead and rotate 90 degrees. Notice it is showing us the arcs and the concentric circles. I think maybe I'll turn those off here. So I'm going to click on this drop-down menu and go to Nothing On. And I'm going to click on Next, and it's showing me slopes of sides of the blue triangle and slopes of sides of the red triangle. And what we're going to try to do is see if there's some kind of relationship between the slopes of the sides and of both pairs of triangles. So right now, if you look at corresponding sides, do you notice anything at all about the slopes of corresponding sides? Any pattern at all? All right, let me grab point B and pull that one here. And do you notice anything about this corresponding side slope now? And I'm going to grab C and pull that one. To maybe right there. And do you see anything in the slopes of corresponding sides there? You might not, just looking for something. So let's return to the PDF. This is on page 5, number 15. And it says we already shown that corresponding sides of triangles rotated about the origin are equal in length. What seems to be true about the pairs of corresponding, what else seems to be true? And we're going to explore that. So what I'm going to ask you to do is to calculate the slopes of corresponding sides of these two triangles. You can either use the slope formula, or I would prefer to use graphically. I think it would be easier to just draw right on the grid right there. Please write all your answers as fractions in simplest form. And then there's a table on the bottom of the page where you can put in your answers in one that says row number 15. While you're doing that, look for patterns. So triangle ABC is rotated about point P, about 90 degrees about the origin. Find the slopes of AB and A prime, B prime, and so on. All right, I'm going to please pause the video, do that, and come back when you're finished. All right, so from 15A, A lines segments AB and A prime, B prime. All right, so looking at the slope of this one right here, looks like we go down 5 and over 1 for a slope of -5 sloping downhill. For segment A prime, B prime, looks like the slope is a positive. If we draw in that right triangle, looks like the change in Y is 1, change in X is 5 for a positive 1/5. And so we're going to record those answers in the number 15 row on the table on the bottom of this page. So just that. Please pause this video if I'm going too fast for you. Then for the next segments, BC and B prime, C prime, slope of BC, it's right here. You can also see it's negative. It's going down 3 and over 6. And it's a simplified fraction, -1/2. Its corresponding side, B prime, C prime, right there. Putting in the right triangle, it's down 6 over 3. It's sloping uphill, so it's a positive slope, 2 or 2 over 1. And we'll record those in the table there. So we've got 2 pairs so far. And the third sides, AC and A prime, C prime. AC is right there, sloping uphill, so it'll have a positive slope of 2/5. and A prime C prime is slanting downhill, slope of -5/2. So we're going to go ahead and put those into the table too. And I'm going to pause just this for a second. All right, so moving on to number 16, similar problem, except the triangles are in different places. This time what we'd like to do is have you do it as we did it here. And don't worry, we'll wait. We'll wait for you. So press pause and come on back. So here are the answers that we got. Double check yours. Press pause as needed to double check them. Make any corrections. Make sure you understand how we got those. Number 17 is going to be a little bit different. So we're going to do the slopes on using the TI-Nspire software. And then we're going to record the slopes there. So for number 17, we're going to go back to the software, and I'm going to reset this. I'm also going to turn off the concentric circles. And I'm going to rotate this, but I'm going to change where the points are. So point A, I want to be at 1, 2. Point C at 5, 3. And at B, -1, 6. So that's where I would like us to do this. So A is at 1, 2, C is at 5, 3, and B is at -1, 6. And so we're going to go ahead and go to the next screen and see the slopes. Notice there is written as decimals. What we'd like you to do is write those as fractions in simplest form in the row 17 video row of the table. So press pause so that you have time to copy those down and simplify them. And remember, we want the slopes as fractions. So you're going to have to make sure you rewrite those as fractions. And then filling in, these are the fractions that you should have. If you write these as like -2 as a whole number, we're fine with that. I'm just emphasizing something here. Press pause as needed. So this is where we've been looking for patterns. What pattern do you notice in this table? And it turns out that the slopes of corresponding sides are opposite in sign in each case, and they are also reciprocals of one another in each case. Opposites and reciprocals. So for example here, what's that mean? It means that the lines are perpendicular to each other, okay? So let's just go ahead and draw those in to see it. So slope of -5 and +1/5. As I extend those out, you can see, yep, they do seem to form a right angle. The other two corresponding sides have slopes that are opposites, reciprocals. Draw those in, and the lines extended out do make a right angle. And the third pairs of corresponding sides, draw those in, extend them out, and yes, they are perpendicular to each other. All right, we could prove that these are perpendicular all the time. This is the so-called proof or argument for it. If you'd like to read through it, please pause and see, if this makes sense to you. And then finally, you can extend this lesson by doing the same exact exercises, but rotate 180 degrees and then 270 degrees. Enjoy. This is the end of the video.